Hello everyone. So this is a question from NEET 2026. The following two reactions give the same foul smelling product Z. Okay, so these are the two sequences. X and Z respectively are. Okay. So the chapters involved is amines and haloalkanes and haloarenes. Okay. So let's say C2H5Cl in the presence of X giving a Z is sequence, it's the first sequence, and C2H5 C double bond O NH2 in the presence of Br2 and NaOH giving us Y, which in the presence of chloroform and ethanolic KOH and heat giving us Z is the second sequence. Okay, so let's look at sequence 2 first. We start with propionamide. So this guy is propionamide, which is a primary or 1-degree amine. Okay, so we have C2H5 C double bond O NH2. So this is a 1-degree or primary amide. So amide because you can see the C double bond O N linkage, and 1-degree because nitrogen is attached to one carbon. Okay, and when a primary amide is treated with an aqueous or ethanolic solution of sodium hydroxide and bromine, it gives a 1-degree or primary amine. So we will get a primary amine. But the catch is that it will have one carbon atom less than the original amide. Okay, so this has one carbon less than this particular amide that we started with. Okay, so therefore, with respect to reactions, I can write, since we are starting with propionamide, CH3 CH2 CO NH2, so it has 3 carbon. Upon reaction with Br2 and NaOH will give us primary amide CH3, sorry, primary amine CH3 CH2 NH2, and the name of this guy is ethylamine, and it has 2 carbons. And also we'll be getting side products, for example Na2CO3, NaBr, and also H2. Okay, upon balancing we will have 2 here, 2 here, and 4 here. So this is the complete reaction. So these are, the side products. Okay, and you can see the starting propionamide has 3 carbon, but the product, that is the primary amine that you are getting, has 1 carbon atom less. It has 2 carbon. Okay, so this is the famous Hoffman bromamide degradation reaction. Okay, so therefore Y, that is this guy, is CH3 CH2 NH2. Okay, which is ethylamine. Which is obviously a primary amine. And when a 1-degree or primary amine is warmed with chloroform and an alcoholic solution of KOH, so when you have a 1-degree amine and it is heated with chloroform CHCl3 and an alcoholic solution of KOH, it gives isocyanides or carbal amines. We get isocyanides, which are also known as carbylamines. Okay, and these guys have very unpleasant odor. Okay, so with respect to reactions, I can write the 1-degree amine is our ethylamine CH3Y, CH3 CH2 NH2. We are treating this with chloroform CHCl3 and KOH alcoholic, obviously heat. So we'll be getting the isocyanide or the carbyl amine, and that is CH3CH2NC. Okay, if you want to see the full bonding, so it is CH3CH2N. This is the whole picture. Okay, so this guy is known as ethyl isocyanide. It is also known as ethyl carbylamine. Okay, and also we'll be getting some side products, for example KCl and H2O. Okay, these are our side products. So when we balance, we'll have 3 here, 3 here, and a 3 here. Okay, and this reaction, that is the conversion of a primary amine into a isocyanide, this reaction is the famous carbyl amine reaction, or it is also known as the isocyanide test. Okay, so therefore Z is this guy, CH3 CH2NC, which is ethyl isocyanide. Coming back to the first sequence, that is C2H5Cl, in the presence of X giving us Z, which is CH3 CH2NC, which we found just now. Here we start with chloroethane, which is a haloalkane, and when a haloalkane is treated with silver cyanide, that is AgCN, we get alkyl isocyanides. And these alkyl isocyanides are also known as alkyl isonitrile or alkyl carbyl amine. Okay, so that is with respect to reaction, I can write C2H5Cl plus AgCN will give me CH3CH2NC plus AgCN. Okay, so therefore our X is AgCN and Z is CH3CH2NC. Okay, there is one important point to consider here. Had we used KCN instead of AgCN, so you can see here we are using AgCN. Had we used KCN instead of AgCN with obviously C2H5Cl, we would have got CH3CH2C triple bond N. CH3CH2, so I will write it down separately. So C2H5Cl with AgCN gives me CH3CH2NC. Same C2H5Cl with KCN, I would have got CH3CH2CN. Okay, and this guy is known as ethyl cyanide. Okay, so this difference in behavior is because in both of them, Cn minus is the nucleophile. Okay, and Cn minus can show resonance. So I will draw its resonance structures. C triple bond N, and this electron pair can shift to nitrogen. So the other structure will look something like this: double bond N, lone pairs, and negative charge. Okay, so you can see either the carbon or the nitrogen can act as electron donors. Okay, so therefore Cn minus is an example of ambident nucleophile. So this is a ambident nucleophile. Okay, so KCN is ionic in nature, so therefore it splits into K plus and C triple bond N, Cn minus basically. Okay, so the reaction can occur through C or N. Okay, but it occurs through C because the new CC bonds are stronger than the CN bond. Okay, so therefore we get alkyl cyanides as the major product. Okay, so with respect to reactions, I can write KCN dissociating into K plus, and CN is this. So it is attacking our haloalkane. Haloalkanes, X will have partial negative charge, R will have partial positive charge. So this CN is going to donate its electron pairs to R. Okay, so it is the nucleophile. So this can happen through either from the carbon or from the nitrogen. But the attack from carbon is preferred because the new C-C bonds formed are stronger compared to the N-C bond. So therefore, ultimately we get, so using arrows, this guy attacks R, X take these electron pairs and go away. So we'll get RC triple bond N and K plus NX minus combining together. That's why we get cyanides with KCl. But silver cyanide is covalent in nature. Okay, so AgCN is covalent. So therefore, only nitrogen's electron pair is available for bond formation. So therefore, alkyl isocyanides are the major product. Okay, that is with respect to reaction, AgCN here is this. So here you can see carbon is making a bond with Ag. So only the electron pair in nitrogen is available to attack our Rx. Rx will have partial negative, R will have partial positive, so it is going to attack. So therefore the new bond is going to be a bond between N and C. So therefore we will get RNC or isocyanides, okay, alkyl isocyanides, and the other product is AgX. So therefore finally our X is AgCN and Z is CH3 CH2 NC. Okay, thank you.